Our universe is full of counterintuitive things. And in this video, we're going to go into 5 counterintuitive things that we see in universe today, and apparently there's no reason why this happens. The space that we live in has 3 dimensions plus 1, the time dimension. But what if I tell you that this information is actually coming from a 2 dimension? It's like you're watching a movie, a 3D movie, wearing those special pair of glasses, seeing yourself in the middle of action, and then suddenly you take your glasses off and you see, well, all the information, all the 3D effects that you were seeing was actually coming from a 2D screen. So all things that you see, perceive as 3D is actually coming from a 2D surface or screen that surrounds the universe. This idea challenges our intuition because we are used to thinking that the world around us has 3 dimensions and everything we see and experience is a result of the interactions in those 3 dimensions. The holographic principle suggests that at a fundamental level, this 3D experience might be a kind of illusion. The real information that makes up our universe is somehow encoded in lower dimensional boundary. Let me tell you this, that this is just a theoretical concept and is up for debate among physicists. Now imagine that I've got a ball and a hill in front of me. If I have to get the ball over the other side of the hill, well, I have to throw the ball, right? And throw the ball with enough power to overcome the hill. But what if I tell you that the ball can reach the other side of the hill, but with lot less energy? So in quantum world, the particle appears on the other side like magically, as if there was a tunnel between the hill and it crossed through the tunnel and magically appeared on the other side. And that is what is quantum tunneling. In everyday terms, it's a reminder that quantum world operates its own set of rules, not governed by classical physics, which is quite different from our everyday experiences. If you don't know, universe expanded to the size of solar system in a billionth of a second. It takes light from sun to reach earth to 8 minutes. How come in a billionth of a second it expanded that much? Well, did it surpass the speed of light? And speed of light is the limit. Then what really happened? How come the universe expanded that big? Now one argument is that it's just the space that expanded. But if the space expanded, then that expansion also needs to cross the boundary, the limit set by the speed of light. You know, that CMB map that shows how universe looked 380 years after Big Bang. So in this CMB map, the temperature is uniform. It should have cold spots and hot spots. Now let me tell you this. If you have a cup of hot water and a cup of cold water, if you try to mix them, it will not come to an equilibrium right away. So when Big Bang happened, it expanded exponentially. It did not have time, because the expansion rate was so high, it did not have time for that energy to exchange. So the cold spot would have been cold spot and hot spot would have been hot spot because there was no way for them to exchange energy. And today in the universe, we should have been seeing these cold spots and hot spots. But wherever we look, we get the same temperature, which is 2.7 Kelvin. It is still up for debate why there's so much uniformity in the universe. Now there are 2 solutions proposed to this problem. One is, of course, we see uniform temperature because of our horizon. We're limited with our horizon. We can't see beyond that. Universe could be much bigger than that. There could be hot spots where we simply can't see. And the other one is, well, the speed of light itself is not constant. It could have been much higher. When Big Bang happened, it let the energy of hot and cold spots exchange and come to an equilibrium. But we don't know. Till now, whatever analysis we have done, speed of light has always remained constant. Now, according to Einstein's theory of general relativity, the massive object not only bends space and time, but also twists and drags space-time as they rotate. Now, this effect is known as frame dragging or lens tearing effect. Means that the rotation of massive object like spinning black hole, can actually drag nearby space-time along with it. So it does not only distort, it also drags the space-time. For example, look at this image of a black hole. You see this tornado kind of effect? Yep, that is lens-thirring effect. And this effect cannot be explained by classical physics. Alright guys, so we have come to the end of the video. Thanks for staying with me, and please do subscribe, like and share this video. Now, if you feel that I left out any topic, please put that in the comment. You can put your views in the comment, and I'll see you next time around. Bye bye.